Hi math students, and this is going to be your lesson on order of operations. Before we get started on the lesson, I have got 3 review questions for us that's really going to help get you starting to think about some of the stuff we're learning in this lesson. The first one is here. I would read that as 2 cubed. The math for that is 2 times 2 times 2, which would give you 8. The next one. This one I would read as a -4 times -6. 4 times 6 is 24, and we learned that a negative times a negative gives you positive. And then this last one says 5 minus 19.3. For this one of the first things I notice is I'm taking away a larger number from a smaller number. That's going to tell me my answer should be negative. In order to subtract these, I'm actually going to change around the order and put the larger number on top and then the 5 below it. When I write 5, I need to write 5.0 so that my 2 decimals line up. And then when I subtract, we get 14.3. Now remember, I had that negative there because we're subtracting a larger number, so my final answer is negative 14.3. What we're going to be doing today is using all of these things here we've learned in past lessons to learn something called order of operations. Our objective for this lesson just says I can simplify expressions using order of operations. Now there's a lot of math vocabulary there in that sentence. Simplify, we know this word already. We know it. We heard it a lot with our fractions and simplifying fractions, but in general, that word simplify just means making stuff simpler. One thing you can simplify is fractions. You could take something like 50 over 100 and simplify that fraction to 1/2 to make it simpler. But in math, a lot of the stuff we do is simplifying. You're taking crazy math problems and making them look simpler. So we're going to be doing that. We're going to be simplifying expressions using order of operations. And order of operations, we're going to talk through today what that is. Before we get too far in the math, I've got a question for you. And my question is this: what is 3 plus 5 times 2? I'm even giving you 2 options. It's either 13 or 16. Go ahead and choose one. Now, I miss doing this lesson in class because when we do this question in class, I'll always ask, okay, who said 13? And about half the class will raise their hand. And then I'll say, okay, who said 16? And the other half will raise their hand. Well, how is that happening? How is it where about half of us are getting 13 and the other half are getting 16? How can you get 13 from this problem? Well, you get 13 if you start here. If you start with the multiplication and say 5 times 2 is 10, and 10 plus that 3 gives you 13. Well, how do you get 16? Well, you get 16 if you start here. If you say 3 plus 5 is 8, and 8 times 2 is 16. So in both those situations, we can see how a student could get 13 or 16. And you probably did one of those things, right? The question is, well, is that okay? We can't have half of people getting 13 and half of people getting 16. No one's making a math mistake, right? No one's saying 3 plus 5 is 100. Everyone's saying the correct thing, but we're getting 2 different answers, which is a problem. We want to be able to look at this math problem or this expression and all agree on a single answer. So what the math community has done, not just in Indiana, not just in the US, but across the world, is we have agreed there is a specific order to do this problem. And we've agreed on a specific order so that everyone can agree on what the correct answer is. And that order is what we're learning today. So I'm not actually going to tell you what the answer to this question is. I'm going to put it to the side for now. And after we go through this lesson, we'll come back to this question so you can see who was right. Now, some of the vocabulary we're going to be using today, as I said, we're learning the order of operations. We want to review real quick what an operation is. In math, there are 4 operations. It's just the 4 types of math. The 4 operations are, I'm going to be a little lazy here. Instead of writing the word, I'm just going to write the sign. Those 4 operations are addition, subtraction, multiplication, and division. Those are the 4 types of math, and those are the 4 things we've spent a lot of time in this class focusing on, right? You guys know how to add, subtract, multiply, and divide anything at this point. Now, when we talk about order of operations is going to tell us the steps to do math in. It would tell me for that last problem what steps I should do those 2 things in and what we should do first. So we saw in that original question, your answer is going to change depending on what you do first. If I've got order of operations, I can use that to tell me which one is the correct place to start. Now, for order of operations, there is an acronym we use in math. Anytime you have a problem that has more than one operation in it, we are going to use PEMDAS to tell you the order. Now, depending on when or where you've learned this, you might have seen PEMDAS in the past. I know a lot of our Nigerian students learn BODMAS. Same idea. There are some math teachers here who use something called PEMDAS. Same thing. We'll use PEMDAS in this lesson just to stick with one way. But if you're familiar with one of these other ones, you'll see how it's saying the same thing. So to get into that, what is PEMDAS? Well, PEMDAS isn't actually a word. It's an acronym, meaning each one of those letters represents something in math. The first thing I want to do before we do any math problems is just go into what each of those letters represent. The P in PEMDAS stands for parentheses. Parentheses. What that means is if you have a problem like this, the first thing you would want to do is any math inside parentheses. In this problem here, that 6 minus 3 is inside those parentheses, so that would be where I start. Some of those other ones I mentioned earlier are BODMAS. That B just means bracket instead of parentheses, but it's saying the same thing. PEMDAS means group, so start here inside this group. They're all the same idea. After parentheses, the E is next, and that E represents exponents. We learned that word in Unit 2. Exponents are just those tiny little numbers here. So it means for a problem like 3 plus 4 squared, I would want to start right here with the 4 squared. After exponents, we have M or D. You can probably guess these two. That is going to be multiply or divide. For multiply or divide, notice I've got them in the same line. The reason for that is because they happen in the same step, and you are going to do them from left to right. Now, what I mean by that is if I have a problem like this that has both multiply and divide, we are going to go from left to right to complete them. So in this particular problem, it means I would do the division first, get an answer, and then do the multiplication. If I had flipped that around, so if it said 4 times 2 divided by 3, in this problem I would be doing the multiplication first, get an answer, and then divide. The biggest mistake students make with this is because in the word PEMDAS, the M comes before D. That does not mean you need to multiply before divide. You're going to work from left to right, so you're going to do whichever one is first in the problem, whichever one's on the left side, and then move right. It's going to be the same thing for these last two, A and S, which you probably can guess are going to be add or subtract. It's the same idea in this problem here. If I'm going from left to right, the addition comes before the subtraction. So here I would start with addition, get my answer, and then subtract. If I had changed that around like this, then the subtraction would happen first. I would get an answer and then add. So you're always just going left to right if you have both of these or if you have both of these. At this point, the main thing I want to make sure you know is what each one of these letters represents. And then there's this rule about left to right if you've got addition and subtraction or if you've got multiplication and division in a single problem. If you've got those things down, you're ready to do some math. I'm going to erase all of this, and we'll get into our first problems. At this point, I want to also point out that there's an order to us doing this. We're not just doing the entire problem, starting here and going over. We have to go through PEMDAS. We have to go through that order for these problems. Part of the mistake students make is that they look at the problem and they try doing it all at once. You're trying to look at the problem and go, okay, the answer is 4. And usually the students who do that are going to make a mistake somewhere. If you're trying to do too much all at once, you're oftentimes going to make a mistake doing something out of order. So I've got up here the advice we're going to follow in our examples today is we're going to make sure we only do one operation at a time. That means if I look at this problem and I say I want to add first, I'm going to add and then just copy everything else down. I'm not going to do any more math. We're going to do one step at a time. So looking at our first example here, one of the first things I notice is there's a lot going on. Specifically, there is 1, 2, 3 different operations. Anytime you see a problem that has more than one operation, more than one thing to do, that's going to be a clue you want to use PEMDAS. Now I'm also going to write it like this, vertically like we saw before, because that's going to help remind me that when it comes to multiplying and dividing and adding and subtracting, there's that left to right rule there. So going through this can kind of be like a checklist for us. The P, do you remember what P is? P is parentheses. So the first thing I want to check to see is, are there any parentheses in this problem? The answer is no. So that makes it nice and easy. We're done with that. Next is E, which is exponents. Do we have exponents? No. Next is multiplication and division. Do we have one of those? Yeah, we've got right here in the middle. I've got 8 divided by 2. That means according to PEMDAS, that's the first thing I want to do. I want to start with that division. When I do 8 divided by 2, I get 4. That 4 is going to go right below where it came from. So I'm not putting 4 over here. It came from the 8 divided by 2, so I put 4 there. And I'm going to copy everything else down. Remember, I'm doing one thing at a time. I did that one step, so I'm just going to copy 2.9. I'm going to copy my plus sign, and then copy my minus 11. And I have just completed over here this step. Now the last step is add and subtract. Do we have any addition and subtraction? Why, yes, we have both of them. We have addition here and subtraction here. What do I want to start with? I want to start with the addition because remember, if you have both of them, you are working from left to right. So I'm going to start off by doing 2.9 plus 4. What's that going to give me? Well, remember to add that, you want to think 2.9 plus 4.0. Since 4 is a whole number, that's going to give us 6.9. I've done one thing. I'm going to copy down the rest. So I'm going to copy down that minus 11. And then here, there's only one step left for us. I've got 6.9 minus 11. What is that going to give us? Well, this is actually kind of similar to that do now question we did earlier. Looking here, I am subtracting a larger number, which is going to be a clue that my answer should be negative. Now, when I actually go to subtract these, you can do it in your head, but if that's too much math to do in your head, if you write them off to the side, make sure for subtraction you're always putting that larger number on top and subtracting the smaller number. When I do that, that's going to give me 4.1, and my 4.1 is negative because I am subtracting the larger number. So I get negative 4.1 for my answer. Remember, our goal is to simplify. Notice I'm taking a crazy looking math problem and making it simpler. I'm saying all of this here, that just equals negative 4.1. Now the other thing I want to point out is the shape of my work. You see how there's multiple lines and it's kind of like a V because it's getting simpler each line? That's what your work should look like. So you shouldn't ever see a problem like this that has all these steps in it and try to jump straight to the answer. Unless you have done a lot of practice with these problems, because chances are something's going to be done out of order, or you might miss a negative sign. Make sure you're giving yourself enough work to look at and enough lines to do all the steps correctly. This was that first example. I've got one more example we're going to try, and then I'm going to have you do one. This next one here is looking even crazier now. I see 1, 2, 3, 4 different operations here, 4 different things for me to do right away. The first thing I'm going to do is write PEMDAS. I am doing this just to help me remember the order I want to use for problems like these. So looking at PEMDAS, first thing I'm checking for is, are there parentheses? This problem doesn't have them, so that's a no. Next is exponents. This problem does have an exponent, so that is where I'm going to start. I'm going to start with my exponent. What does that equal? Remember, 4 squared, the biggest mistake students do is they do 4 times 2, but that's not what this says. 4 squared means 4 times itself, 4 times 4, which gives you 16. I've done one thing, so all I'm going to do now is just copy everything else down. And I'm going to come over here and cross off my exponent. Done my parentheses, done my exponents. Next is multiplication and division. What should I do in this step? Well, I've got both multiplication and division, but remember, if you have both, you want to go from left to right. So which one comes first? The division does. So that is going to be where I start. I'm going to say 10 divided by 2 gives me 5. I've done one thing, so I'm going to go ahead and just copy everything else down for myself. And then now that we've done that division, now I can finish up the multiplication and say 5 times 5. 5 times 5 gives me 25. And so I copy my 16 down, get 16 plus 25. And then at that point, I finish this step. If I come back, it tells me to do add and subtract. I see 16 plus 25. You might have already done it at home. 16 plus 25. We can finish up this by saying that gives me 41 there. Again, I want to point out I'm only doing one thing each step and then just copying everything else around it until I get my final answer, which is just that single number there. It is time. It is time for you to try one. So you're going to be trying this one. Your problem says 7 plus 3 squared minus 20.3. Go ahead and try that now. All right, so for this problem here, if I'm going through PEMDAS, there are no parentheses. There is an exponent, so you wanted to start there and say 3 times 3 is 9. Copying everything else down. After that, you're looking for multiplication and division, but there isn't any. There is addition and subtraction, though. We have both of those, so you should have gone from left to right. When you add, that would give you 16. And then when you do your subtraction, 16 minus 20.3 is negative because we're subtracting a larger number. It would be negative 4.3. We have got one last set of examples left. These last ones, you might notice all of our problems we've done so far have not had parentheses. Save the parentheses for last. So in this first example here, we have got 5 times 12 minus 6 in parentheses, and then that is squared. Again, I see there's a lot going on here, so that is a clue that I want to use PEMDAS to help me figure out the order. So there it is. In this problem, first thing I'm checking for, are there parentheses? Yes, there are. So that is where I'm going to start. Specifically, I am starting inside these parentheses here. Inside the parentheses, it says 12 minus 6. So that's the math I'm going to start with. I'm going to say 12 minus 6 is 6. Now, when people copy down the stuff around the 6, sometimes a mistake is made. Sometimes students will say, okay, I did the 12 minus 6, got 6. I want to copy the 5 down, and I want to copy squared. What is wrong with what I just wrote? Well, notice here I did not copy down those parentheses. Now, sometimes you don't need the parentheses, but here they're really important. Here those parentheses are important because if I don't have parentheses there, it doesn't say 5 times 6 squared. It says 56 squared. That's not what we're trying to say. I need those parentheses there because it's showing me the multiplication, so I can't take them off yet. We've done our parentheses. Next would be exponents. So the next thing I would have is, I see I've got 6 squared. That's what I'm going to do next. I'm going to say 6 squared equals 6 times 6, which is 36. And then again, if I copy down my 5, if I write it like this, that says 536, which we don't want to say. I need to copy those parentheses to show the multiplication. My last part, well, the last thing I have to do is, what is 5 times 36? I am going to have to write those like this to multiply. When I do that, I see 6 times 5 is 30, and then 5 times 3 is 15, plus our 3 gives me 18, so I get my final answer is 180. I've got one last example with these parentheses. Over here, we've got 2 plus 3.1 times 4 minus 1.7. Again, I'm going to use PEMDAS to help tell me the order I want to do this problem in. When I am looking at that, it says start off with your parentheses. Well, here if I look at my parentheses, I notice there's a lot going on. There's actually 2 things inside those parentheses. There's addition and multiplication. What do you think I'm going to do first? Well, if you've got more than one thing in your parentheses, you treat it kind of like a mini problem. So you're going to go back to PEMDAS and say, well, inside the parentheses, I've got addition and multiplication. What would come first? Well, multiplication would come before addition. So when I go to do my parentheses, I'm going to use PEMDAS again to say, let's start with the multiplication. If I do that multiplication, 3.1 times 4, that's going to give us 12.4. And I'm going to keep my 2 plus 12.4 in parentheses because I haven't finished everything in the parentheses yet. And then minus our 1.7. Now remember, I'm working on parentheses. I'm still not done. I did the multiplication in parentheses, but I still need to do the addition. So I need to do 2 plus 12.4. What would that be? Remember, 2 is a whole number, so I'm adding 12.4 plus 2.0. That's going to leave me with 14.4 minus 1.7. Now notice this time is different than over here. You could put the parentheses if you want, but we don't need those parentheses. The parentheses aren't being used to show multiplication. All we were using them for was to kind of show this is all together. This is one big group. This is what we want you to start with. It has all of those meanings, but here I finished everything in the parentheses. We're not using them to show multiplication, so they're not necessary. The last line is just going to say 14.4 minus 1.7. What does that give us? Well, to subtract those, I would probably put them on top of each other. That way I can see I need to borrow to get 12.7. Our final answer is that's going to simplify to 12.7. Now those 2 are my example problems. The last thing for you to do is this problem over here. Go ahead and try this one now. Well, in this problem here, again, we would want to start inside our parentheses. Inside our parentheses, there are 2 things to do. I see a 5 squared and I see a minus 10. If I'm using PEMDAS, exponents come before subtraction. So I would want to start with that exponent and say 5 squared, that's 5 times 5. That is 25. So I have 25 minus 10 in the parentheses. To finish up our parentheses, we would say 25 minus 10 gives me 15. Now I still need those parentheses there to show that multiplication part. So my last step is 2 times 15. 2 times 15 equals 30. And that would be our final answer. The question from the beginning of the lesson is now something I think you're able to do. Remember the question we had at the beginning that I told you I wasn't going to tell you the answer for? That question was 3 plus 5 times 2. What was the correct answer? For this one, we need to start with that multiplication, which would give us the 10, and then when we add, we would get the 13. If you got 13 at the beginning of the class, awesome job. If you got 16 at the beginning of the class, awesome job, because all that means is you've learned something in the past 20 minutes. The last part of this lesson goes into how we can use order of operations to represent word problems. I'm going to skip that. So this last part here is using order of operations to represent word problems. I've got 2 examples we're going to look at of a word problem that would require more than one step. Now in the past, if it's required more than one step, I haven't asked you to write an equation yet because there's a specific way you need to write your equation. We've been seeing all these problems if there's more than one step that corresponds to a specific way the problem is written. The idea is the same here. So for example, I've got the problem Denise wants to buy 3 Indiana University shirts for her 3 family members. Each shirt costs $15. If she pays with a $50 bill, how much change should she get? Now I've asked you to do problems like this before. Go ahead, don't worry about the equation yet, just go ahead and find an answer for me for this problem. Well, in order to figure out how much change she should get, we know what she's paying with, but we need to figure out how much that total cost is. So one thing I would need to do is take the cost of each shirt and multiply it by how many shirts she's buying. So I could take that $15 for each shirt times the 3 shirts she's buying. That gives me a total of $45. And that is, I'm just going to label it, the total spent. If I want to figure out how much change she's getting back, well then we're taking that $50 she's paying with, subtracting out the amount of money she spent, and then that's going to tell me she should get $5 in change. So I could say the answer to the question, how much change should she get, is $5. Now we've got our answer. The reason I told you to get the answer first is let's use some of this math we did to help us write an equation. The first thing we did is we did 15 times 3. So I'm going to put that down. That's going to be part of my equation, 15 times 3. You can write it with that multiplication sign. You can write it with parentheses, a dot. I don't care how you write that multiplication, but that's going to be somewhere in our equation. Now, after we multiplied, what did we do? Well, the next step is subtracting. We took our $50 and subtracted the total amount of money she spent. So in my equation, we also need that subtraction. The challenging part for students sometimes is figuring out where does that go. Well, notice this 15 times 3, I put the answer right here. That means I need that 50 in the subtraction sign before the 15 times 3. We are taking that $50 and subtracting the cost. That 15 times 3 there, that represented the cost of the shirts. So for our equation would say 50 minus 15 times 3. And then we've done this in the past to make it an equation. You just says equal, I don't know. That's what we're trying to figure out. Now the last thing I want to check is if I were to give you this problem, would you complete this problem in the same order as this, using what you know now about order of operations? Well, if I gave you this problem, the first thing we would do is we would do that multiplication, the 15 times 3, which gives us 45. And then I would subtract 50 minus 45, which gives us the answer we wanted. So that last part is, let's just check to make sure I've written it in a way that gives me that answer we already figured out. Now this is an example of a 2-step word problem. There's 2 operations. There's 2 things we had to do. I've changed this question just a little bit so that there's more going on for this second example. So again, we have Denise, and it tells us Denise wants to buy Indiana University shirts and mugs for each of her 3 family members. Each shirt costs $15 and each mug costs $10. If she pays with a $100 bill, how much change should she get? So a similar situation, but I've added in some extra information. Notice this time she's buying shirts and mugs, and the amount of money she has changed. Again, I'm going to have you go ahead and find the answer to the question. Don't worry about the equation yet. Just go ahead and figure out how much change she should get. Well, the strategy is similar to before. The difference now is she's spending more money. Just like before, I would find the total cost of shirts. So we got each shirt is $15, and she's buying 3 of them. So $15 times the 3 family members means she's spending a total of $45. I'm going to label it on shirts. She also is spending money on the mugs. So I can say she is spending $10 on each mug times her 3 family members. 10 times 3 gives me $30, and that is on the mugs. To figure out how much change she should be getting back, we're going to take the amount of money she's paying with and subtract the total amount of money she's spending. So I've got this information here, but I'm going to go ahead and put it together to find the total she has spent. If I want to do that, I'm taking the $45 she spent on shirts and adding in the $30 she spent on mugs, and that tells me she has spent $75 total. So I'm going to say the $75 is the total she has spent. Then my last step is taking the $100 that she has, subtracting the amount of money she has spent, and that's going to tell me she should have $25 back as change. So in this problem, we've got 4 steps we were doing. Now I've already got the answer. I figured out she should have $25 in change. But how can I represent all of this math in a single equation for this problem? Well, similar to before, I'm going to go through one part at a time and add it to my equation. So the first thing I did was I figured out the total of the shirts. So part of my equation is going to say 15 times 3. Another part of my equation is going to say 10 times 3 for the mugs. So I'm just going to put it over here, 10 times 3. Now this next step here, what was I doing? Well, I was adding the total amount of money spent on shirts plus the total amount of money spent on mugs. So in my equation here, I'm taking the amount of money spent on shirts and adding the amount of money spent on mugs. Now the last part, what am I doing here? Well, I'm taking that $100, that total amount of money she has, and I'm subtracting that total spent. So I'm subtracting all of this. Again, in this problem here, that 100, notice, is coming at the front. In my equation, I need the 100 at the beginning, and then I am subtracting all that money she spent. Now I've written it like this, but there's a mistake here. There's something I need to change, something I need to add, there's something I need to do. Do you know what mistake I have right now? Well, I tried to give you a clue when I said we're taking the $100 and subtracting all the money she spent. If I want to show that we're subtracting all of this, right now that's not what it says. It just says we're subtracting the 15 times 3. For me to show I want to subtract all of this, we need parentheses there. Those parentheses are showing that all of this here is together. It's showing all of this represents the amount of money she spent. Those parentheses are also really important when it comes to doing the math. If I gave you a problem like this, we would want to start off inside those parentheses. So that 100 minus would just come down. And then in the parentheses, if I start with the multiplication, 15 times 3 is 45. And then the other multiplication, 10 times 3 is 30. Notice we get 45 plus 30. That's just saying the 45 on the shirts plus the $30 on the mugs. Those parentheses are telling me the next thing we want to do is add those together. Notice in my work, the next thing I did was add those to figure out the total spent. That is why this next line is going to say 100 minus 45 plus 30, which is 75. Then the last part is just 100 minus 75, which gives us our answer. I think especially these problems with parentheses can be a little tricky. You want to use parentheses when you're trying to show a group of something like this. So in this problem, I was trying to show that we wanted to subtract all of this. And I'm putting all of this together in a group because this is all representing the money she's spending. I'm going to go ahead and erase all of this. There is one last word problem. This one is all you. This one here says Brian and Carlister go out to eat. They order some appetizers for $10 and a pizza for $12. If they want to split the cost of the meal, how much should each person pay? Go ahead, write an equation like we were doing before and find the answer to this question. I'm looking for an equation and an answer. For this one, I'm not going to do all the math, but I do want to show you what it would look like. In order to figure out how much each person would pay, we want to figure out the total cost of the meal and then divide it by how many people are paying. Our total cost of the meal is the $10 for the appetizer and the $12 for the pizza. Now, they want to split the cost. That means I want to divide it by the two people. I can't write this though, because the problem with that is saying we're just doing 12 divided by 2. We want to show they want to split the entire cost of the meal. We need parentheses there. That would show me I want to add all of this up to figure out the total cost first, and then after I've got the total cost, then divide by 2. If you write 10 plus 12 divided by 2, that means they're only splitting the cost of the pizza and not the cost of the appetizers. The rest of that, the math, you can do, I'm sure. Thank you so much for watching this lesson on order of operations. I'll see you guys tomorrow. Bye.